Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Today we will learn about integration by substitution. By the certain case when we cannot solve the integration by manually, so we need to use the integration by substitution. So in order to solve integration by substitution, we have 5 steps. Okay, so let we look at one by one. Okay, for the first step, when we want to solve by using U-substitution, so we need to identify our U first. So how to identify our U? So we look at our question whether we have a long function of denominator, or we have the term with the highest degree, or we have the term inside of the radical. So we need to consider these 3 terms in order to make our function as U. So second step, after we identify our U, so we need to find the differentiation of the U, which is du over dx. Okay, then the third step followed by substitute U and du over dx into the integration. Then we simplify that integration, and then step number 4, we integrate that function and we return to the initial variable of x. Okay, look at example 12 here. Evaluate each of the following integral by using the appropriate substitution. So for the first solution, which is integration of 5x over x squared plus 1. So for this function, we cannot solve by using manual integration because we have the long function at our denominator. So consider the 3 term that we need to use as our U here. So we need to make our denominator as U, since our denominator is a long function which is have operation of plus or minus. So we let our U is equal to x squared plus 1 here. So we differentiate our U, then we will get du over dx is equal to 2x. Then we make our dx, okay, our dx as our subject, then we will get dx is equal to du over 2x. Okay, then we substitute our u and du dx to the integral and simplify. So our 5x over u, since we already take our u is equal to x squared plus 1, and dx is equal to du over dx. So we replace our dx now with du over dx, since we have find our dx is equal to du over dx. So from here we can simplify x and x we can cancel. So what left is 5 du over u times 2. So 5 over 2 is a constant. So we put our constant in front of our integration symbol. So what we need to integrate only 1 over u du. So based on our previous learning, so when we have 1 over u and we want to integrate, it becomes ln u. So our answer should be 5 over 2 ln u plus c. At the end, we need to substitute back our u, which is our u is equal to x squared plus 1. So our final answer should be 5 over 2 ln x squared plus 1 plus c. Okay, B, integration of 0 to x squared times x cubed minus 7 power of 5. Okay, if you look at this function, the power of this function is 2 highest, which is 5 here. So we no need to expand this bracket because the power is too high. Okay, if you have a function with the power of 2, it's okay to expand, but if you have a function greater than 2, let's say 3 and above, so you need to use U-substitution in order to solve that question. So what is our U? We need to put our function with the highest power as our U. So we choose our U is equal to x to the power of 3 minus 7 here. So when we integrate that u, we will get du over dx is equal to 3x squared. So from here, we make our dx as a subject, then we will get our dx is equal to du over 3x squared. So we write down back the original question is equal to x squared times dx. Okay, we already replace our dx with du over x squared, and our x cubed minus 7 is equal to u. So we replace with u here. 3 power of 5 multiplied by du dx is equal to du over 3x squared. So from here we simplify our x squared at numerator, we cancel with x squared at denominator. So what left is 1 over 3 as a constant. We put in front from our integration symbol, and what we need to integrate only u to the power of 5. So when we integrate u to the power of 5, so we will get u to the power of 6 over 6. Okay, so when we want to substitute the definite value for this integration, which is 0 and 2, don't forget to replace back our u into this equation, which is our u is equal to x cubed minus with 7. Okay, so we substitute our x with 2 first, followed by substitute our x with 0. So when we substitute x with 2 and minus with x equal to 0, then we will get the final answer for this question is equal to negative 6536. Example 13, we need to integrate 2x square root of x minus 3. So for radical function, we cannot expand or solve manually. So we need to use U-substitution. So look at our first condition previously. We need to find whether our U is the highest degree, okay, function with the highest degree, or we have denominator or radical, or okay, inside the terms inside radical. So this case, our u is the term inside of the radical, which is x minus 3. So we take our u is equal to x minus 3, then when we integrate when we differentiate du over dx, we will get 1. So du is equal to dx. Okay, so what left is 2x square root of u du. So when we want to integrate in terms of du, so all the variable here we need to use du. We need to use in terms of u. We cannot use x here. So what we need to change here, the variable x here we need to replace with u. So what we need to do is our u actually is equal to x minus 3. So we make our x as a constant because we want to substitute the value of x here in terms of u. So x becomes equal to u plus 3. Okay, so we write down original question back, which is 2 is a constant. So we put our constant in front, which is 2 in front, and integration symbol 7 to 12. Okay, then followed by x, which is x is equal to u plus 3. So we put u plus 3 at x and then square root of u. So from here, we can expand our function one by one. So we just expand, okay, open the bracket. So u multiplied by u power of 2, then we will get u power of 3 over 2 plus with 3 u to the power of 1 over 2. So from here, we can integrate that function. Then we will get 2u to the power of 5 over 2 over 5 over 2 plus 3u to the power of 3 over 2 over 3 over 2. Okay, then from here, we simplify and we take over 5 over 2, we rearrange back, then we will get 2u to the power of 5 over 2 over 5. Okay, and plus with 2 over 3 times 3u to the power of 3 over 2. Okay, then we simplify that function until we get here like this. Okay, because 3 over 3 we can cancel. Okay, then before we substitute the value of x with the numerator, with the definite number of integrals 7 and 12, don't forget to replace back our u, which is our u is equal to x minus 3 here. Okay, don't forget to replace our u before you substitute the value of x with 7 and 12. So after we substitute the value of u with x minus 3, then we solve, we will get our final answer is equal to 1224 over 5. Integration of x squared over x plus 1 dx. Let our u is equal to x plus 1. We cannot simplify this by using normal integration because our denominator have long term of function. So we make our denominator as u, which is u equal to x plus 1. So that we need to differentiate that function du dx, then we will get u dx is equal to 1. Then our dx is equal to du. Okay, so x plus 1, we need to replace with u, and dx equal to du. We just substitute the value of dx is equal to du. So from u equal to x plus 1 here, we make our x as a subject in order to take our function x in terms of u. So we will get x is equal to u minus 1. So from here, we substitute the value of x into the given function, which is u minus 1 square over 2. So when we open the bracket, okay, then we will get for numerator, which is u square minus 2u plus 1 over u. So when we separate one by one for numerator and denominator, we will get u square over u minus 2u over u plus u over plus 1 over u. Then we simplify this function and we will get u minus 2 plus 1 over u. So after we simplify this, then we integrate that function and we will get u square over 2 minus 2u plus ln u plus c. And then at the end, don't forget to replace back the value of u, which is u equal to x plus 1. So the final answer should be x plus 1 square over 2 minus 2 times x plus 1 plus ln x plus 1 plus c. Example 14. 1 minus sine to the power of 4 theta cos theta. So 1 minus sine power of 4 theta quite high, but it's not outside from the integration symbol. Okay, so we can choose either one. Maybe 1 minus sine power of 4 theta or cos theta. Okay, so we use try and error to solve this. So that we use our u is equal to sine theta. So from here, when we make our du over d theta, we will get cos theta d theta. So d theta is equal to du over cos theta. So then we replace the value of sine with u power of 4. Okay, why we not take the power itself? Because when we integrate, when we differentiate sine power of 4, then we will get the highest power of that function, that figure also. Then that's why we only put our u as sine theta only, so that we can solve by cancel our cos theta here, which is cos theta over cos theta is equal to 1. Okay, so what left is 1 minus u to the power of 4 du. So from here, we only integrate that function by manually, so that we will get our function is equal to u minus u to the power of 5 over 5 plus c. Okay, then we substitute our u with sine theta. Okay, then our final answer should be sine theta minus sine to the power of 5 theta over 5 plus c. Question B, example 4. Square root of cos 3 theta sin 3 theta d theta from 0 to pi over 2. Okay, so we let our u is the function inside of the radical. So our u is equal to cos 3 theta. Then we integrate, we differentiate this du over theta, we will get 3 sine 3 theta times with 3. Okay, then our 3 we make and put it in front, then we will get negative 3 sine 3 theta. So our du is equal to negative 3 sine 3 theta d theta. So we make our d theta as a subject, then we will get d theta is equal to du over negative 3 sine 3 theta. Okay, so from here we use back our original function. Okay, our cos theta is equal to u, so just replace cos theta, cos 3 theta, then we will get square root of u sine 3 theta. D theta is equal to du over negative 3 sine 3 theta. So from here we can simplify sine 3 theta. We can cancel by sine 3 theta at denominator. And what left if negative 1 over 3 as a constant we put in front of the integration symbol. So we will find our integration only square root of u of du, okay, which is equal to u power of 1 over 2. So that we integrate u to the power of 1 over 2 and we will get u to the power of 3 over 2 over 3 over 2. So that we will get negative 2 over 9 u to the power of 3 over 2. Okay, don't forget to replace or to substitute back our original u, which is cos 3 theta. Then we will get cos 3 over 2 3 theta. Okay, then we substitute the value of theta with pi over 2 minus with 0 here. So at the end, when we press our calculator, we will get the value for this integration is equal to 2 over 9. Evaluate each of the following integrals using the appropriate substitution. Okay, the first one is tangent to x dx. So tangent we can change to sine to x over cos x, and we make our denominator as u. So u equal to cos 2x. Okay, differentiate u du dx, then we will get negative sine 2x multiplied by the differentiation of 2x is equal to 2. So 2 here we put in front of 3 go, then we will get negative sine 2x. Okay, we make our du dx as a subject, then we will get dx is equal to negative du over 2 sine 2x. Okay, so from here we simplify, we integrate sine 2x over u, which is cos 2x, we already replace with u. Then the value of dx we substitute with du over negative 2 sine 2x. So we can simplify or cancel sine 2x here. So negative 1 over 2 is a constant we put in front of the integration symbol. So what happened? What left in our integration? Only 1 over u du. So when we integrate 1 over u du, we will get ln u. So our final answer, we need to substitute back the value of u with 3 go value, which is cos 2x. And we will get negative 1 over 2 ln cos 2x plus with c. B, square root of sine x cos cube x dx. So we need to take our function inside of the radical as our u, which is u equal to sine x. So we integrate or we differentiate this u, then we will get du dx is equal to cos x, and our dx is equal to du over cos x. So we substitute the value of sine x with u, and we change the value of dx with du over cos x. So when we cancel this cos x at denominator and numerator, we will get square root of u cos square x du. And we substitute cos square x by using identity of trigonometry, which is cos square x is equal to 1 minus sine square x. Okay, then we replace sine square x with u square, since previously we have declared that our u is equal to sine x. So that we will get 1 over 2 integration from 0 to pi over 2. square root of u times 1 minus u square du. So we expand this bracket and we will get u to the power of 1 over 2 minus u to the power of 5 over 2. Then we integrate this function, we will get u to the power of 3 over 2 over 3 over 2 minus with u to the power of 7 over 2 over 7 over 2. So then we cannot left our answer like this because it's very too much per here or fraction here. So we need to change to the term 2 over 3 u to the power of 3 over 2 minus with 2 over 7 u to the power of 7 over 2. So then from here we substitute back the value of u, which is u is equal to sine x, and after substitute the value of u, then we substitute the value of x with pi over 2 and 0. So from here we substitute the value of x with pi over 2 and 0. Then we will get the final answer is equal to 4 over 21. Question C. Integration of 4x squared sine x cubed dx. So our u is equal to x cubed, du dx is equal to 3x squared, and our dx is equal to du over 3x squared. So we substitute our u, which is x cubed, and our dx is equal to du over 3x squared. So when we integrate sine u du, we will get negative cos u plus with c. Okay, so negative we put in front of negative 4 over 3. Then we replace back the value of u. Then we will get our final answer is equal to negative 4 over 3 cos x power of 3 plus with c. Sigma notation. Okay, this is the symbol for the sigma notation. Sigma means summation up, sum up. Sum is summation. Okay, so means if you have the symbol of sigma here and you have a function of n starting from n equal to 1 until n equal to 4. It says that we goes from 1 to 4, which is 1, 2, 3, and 4. Okay, for example, we have summation of n from n equal to 1 until n equal to 4. So when we sum all of this number, we will get 1 plus 2 plus 3 plus 4. Then we get final answer is equal to 10. Or we also can write like this. Summation of n from n equal to 4 from n equal to 1 until 4. So we need to start it with the lower value of n, which is 1. And the upper limit or n value of n is 4. And what we want to sum is n. Okay, so our function is n here. Okay, so for example, if we have a function of n squared, so we need to summation or sum up the value of 1 until 4 for the given function n squared here. So when we substitute, we will get 1 squared plus 2 squared plus 3 squared plus 4 squared, and then we will get the answer of summation n squared from n equal to 1 until 4 is equal to 30. Okay, so second example, if we replace the function with 2n plus 1, so we just substitute the value of n equal to 1 for the first term and n equal to 2 for the second term, n equal to 3 for the third term, and n equal to 4 for the fourth term, and we sum out all of this, then we will get equal to 24. Okay, so example C, if we have a function 1 over I plus 1. So doesn't matter what is the function, whether n, I, s, don't confused. You just replace the value of that variable with the starting value until n value. So for the first term, we replace our n starting with I equal to 3. So when we replace our I equal to 3, we will get the first term is 3 over 4. And for the second term, when we replace our I is equal to 4, we will get 4 over 5. And for the third term, when we replace our I equal to 5, we will get 5 over 6. And we sum all here, then we will get the final answer is 143 over 60. Okay. Number D, summation of 2 to the power of k from k equal to 0 until 5. So we just start from k equal to 0 and with 5. So our function should be 2 power of 0 plus 2 to the power of 1 plus 2 power of 2 plus 2 power of 3 plus 2 power of 4 plus 2 power of 5. And then our final answer should get 63. Okay, so definite integral with the sigma notation is become like this. Okay, from the integration symbol, okay, it's become the summation of that fx from I to the is equal to 1 until n. Okay, that's why the definite integral and sigma notation have a relationship here. Okay, so the delta x is equal to b minus a over b. Okay, so the second one is the integration symbol here is integration signs introduced by Leibniz. And the definite integral from a to b fx dx, which is a is a lower, b is the upper limit, and fx we call is integrand, and dx is the independent variable of x. If we have integral from a to b fx dx, okay, it also can be integration of a to b ft dt, or it also can be integration of fr dr from a to b. Okay, then we have the sum up function, okay, sum up symbol here for fxi delta x starting from I equal to 1 until n. Okay, so let's say we have a summation of I equal to 1 starting until n, and we have a function of si to the power of 3 plus with si sin si. So delta x for the interval of 0 pi. Okay, this will be 0, integrate from 0 to pi, which is x to the power of 3 plus x sine x. Okay, so this summation symbol, sum up symbol, we can change into the integration symbol like this. Okay, so we have several properties in the definite integral. So the first properties is when we have a constant c, okay, integrate from a to b, and we have a constant dx. Okay, so we no need to change anything with our c, just write down back the value of constant itself, and then what we need to solve only for b minus a. Okay, properties b, if we have a function times with the constant dx, integrate for the definite integral from a to b, so we need to put outside our constant, and we only integrate the function of fx dx from a to b, where c is any constant. Okay, so properties number 3, if we have a function of fx plus or minus gx dx from a to b, so we can separate like this, which is integration of fx dx from a to b plus minus integration of gx dx from a to b. Okay, and properties number 4, we have integration of fx dx from a to b. We also can change to fx dx integrate from a to c plus with integration of fx dx from c to b. Properties number 5, we have fx dx from a to b, but if you want to change the integration number here, so it's become negative integration from b to a fx dx. Properties number 6, if we have a function of fx dx and the upper and lower limit is equal, then we will get the value is equal to 0.